Hi, my name is Pi. I'm a math tutor, and I want to give you a little bit of an example of what it's like to work with me doing math problems. So let's just dive right in. I'm going to start today with a classic algebra problem. These are huge on the SATs and ACTs if you do them, but they're also really big in any algebra class that you're ever going to take. So let's take a look at this problem. Regina is buying baguettes and croissants at a local bakery. 2 baguettes and 1 croissant cost $13. 3 baguettes and 2 croissants cost $22. How much does 1 baguette and 1 croissant cost? Okay, so there's 3 main ways that I can think of to go about doing this problem, and I'm going to take you through all 3. Because some people work differently, and I want you to be able to do the way that works best for you. So stay till the end because the third way is by far the fastest. All right, so first we want to take a look at these statements. When you have these kinds of problems that are like 2 baguettes and 1 croissant, or 5 rolls and 7 cars, and things like this, where they give you combinations of things, this is going to be a certain kind of problem called system of equations. So what you need to do is identify your variables. What is it that we're trying to find? Baguettes and croissants. We want to find the cost of that. So let B equal the cost of 1 baguette. And let C equal the cost of 1 croissant. So 2 baguettes and 1 croissant cost $13. Now, this is going to lead us to the equation 2 baguettes and 1 croissant cost $13. Cool. The next one is 3 baguettes and 2 croissants cost $22. 3 baguettes and 2 croissants cost $22. Now, way number 1, method number 1. This is the substitution method. This is the one that is by far the most common in students. What you do is you take the simpler of the 2 equations, usually the one that has a 1 in front of one of the variables. You solve for that variable. So we take 2b plus 1c equals 13. We solve for c by subtracting 2b from both sides, and we get c equals 13 minus 2b. Now we take that and we put it into the second equation where c would be. So instead of writing c, we write this. What this does is this is going to make it so that we can have our equation in fewer variables. Okay? So we will have 3b plus 2, and not c, but instead of that, 13 minus 2b, which is what we've got there, equals 22. Now what we are going to do is well, that just sort of gets all gross. Anyway, what we're going to do is we are going to then solve this. This is now solvable because it has only 1 variable. So we start by multiplying through this 2. We distribute. 2 times 13 is 26. 2 times negative 2b is minus 4b equals 22. Combine like terms. Negative b plus 26 equals 22. Subtract 26 from both sides. Negative b equals negative 4. Divide both sides by negative 1, and we get b equals 4. Cool. We take that and we put this in here. And we're able to get the cost of a croissant. 13 equals, or c equals 13 minus 2 times 4, which equals 13 minus 8, which is 5. Now, this is all just becoming a whole big mess there. All right, cool. Let's do that. Now, what we're going to do here is realize the question is asking for not what's the cost of one croissant or one baguette, but the croissant and one baguette. So we just need to do B plus C. Cost of one baguette is 4. The cost of one croissant is 5, and the answer is 9. So that's the first way, substitution. Solve for one, plug it back into the other equation, and you get the final solutions. Another way to do this is we have, let's see, it's the method 2. This one's called linear combinations or other names. What is that called? Okay, so method 2 for solving a system of equations is called adding and subtracting, because you add and subtract them together. So what we do here is we're going to find a proper way of adding these two equations together so that one of the variables goes away. So method 2 is adding and subtracting. There are other names for this, and I think it's like linear combinations. It makes you sound more intelligent when you say linear combinations, so we can also call it that. But adding and subtracting is the main idea. What I like to think of for this, the main strategy for this method, is for matching opposites. So let's take a look at this. We want one of these coefficients. Coefficients are the numbers in front of the variables. We want them to match and be of opposite signs. You'll see why later. So first, the easiest one to deal with is the C. So what we're going to do is we're going to take this and we are going to multiply this top one, this top equation, by -2 all the way through. What that's going to do is create -2 times 2b is -4b. -2 times 1c is -2c. And -2 times 13 is -26. Make sure you multiply both sides of the equations. Students love to forget one. Now, then there's 3b plus 2c equals 22. Now notice these two coefficients here, they match. They're both 2's, but they're of opposite signs. So when I add the two together, add the two equations together, we have the big old plus sign right there, we're going to get -4b plus 3b, which is just going to be -b. These two cancel, which is awesome. -26 and 22 make a -4, just like we did in the previous part of this problem. So then b equals 4. Then you would take that solution, plug it back into either of these equations. It doesn't matter. I always suggest the simpler of the two. So we go here. We get 2 times 4 plus 1c equals 13. We get 8 plus c equals 13. Subtracting 8 from both sides, we get c equals 5. Similarly, b plus c, to get the cost of a baguette and a croissant, is 4 plus 5, which is $9. Now, method 3 is going to be, it's also an adding and subtracting, but it's like, this only happens if you're kind of lucky, and happens a lot on SATs because they want to see if you're paying attention, and it saves you a lot of time. So method 3 is really just a lucky method 2. And we'll call it that, the lucky method 2. So what we have here is the same set of problems, but what I'm going to do is I'm going to switch the order. We're going to make it 3b plus 2c equals 13, and we're going to make it 2b plus 1c equals, 3b plus 2c equals 22. Oh dear. And 2b plus 1c equals 13. Now, the reason this works, what we're going to do is we're just going to subtract the second equation from the first. Just one big subtraction. You have to just keep your eye open and see if this happens to work. And it often does on the SATs. They don't want you to be spending hours solving things. So 3b minus 2c is 1b. 2c minus 1c is c. And 22 minus 13 is 9. Now, you don't find out the individual values of the baguette and the croissant, but nobody cares because what we really want is the baguette with the croissant. So, I've shown you 3 methods. The way you choose is, well, of course, up to you. Let me know which way you prefer, and love to see you in the future. Have a great day.